So here I am back at the Submarine function generator or signal generator. It has been a while since I have done something to it, so it's about time to make some progress. So my plan for today is to make a couple of, or one test lead that I can use with this function generator. I have not figured out what kind of sockets that these terminals are, so I can't find anything that's factory produced and will fit these types of sockets, so I need to make the plugs myself. So as you can see, it's much like a cigarette lighter socket in the car, or the 12 volt socket in your car. It has this wide opening and then a narrow opening inside. So my plan is to make something like this. Sorry for my crude drawing here. So here is my drawing. Looks like a kid has drawn it, but so my plan is to have a center pin that is spring loaded. I'm gonna use some aluminum to make my parts. Then I'm gonna 3D print something to isolate the center pin from this part here. So let's see what I can make. So first I will make this sleeve here, I think. So I will turn down my aluminum bolt to 11 millimeters and try it in the function generator, see if it fits. It is a spring inside the socket in the function generator that presses against this part, so my diameter isn't that crucial. It can be some play in it. Let's see where we are. So that's not much off from 11. Let's see if it fits in the socket. So let's see if it fits. Got a bit, could be a bit wider. I could have added maybe I should try 12 instead. but the spring presses nice here at 11, and I need to think about the center pin that is going in the center, and the spring on the side here needs the room to in between. So maybe 11 is enough. Can try out 12. There, I made one in 12. Then I made a 4mm center tap just to test if my plan works. This fits more snug than the 11. And the center tap goes into the hole also. Fits both terminals. Cool. So then I can cut off this part. Then I'll start to make a hole in the sleeve here, or make a sleeve out of this bar. So the center tap is gone, so I need to drill a center hole for guiding my 8mm drill bit. So I will so I will drill center hole here to 8mm. Then I got 2mm walls on each side, doesn't I? Because I got 12. Yep, 12, 8, 4, 2. Good morning. So I have drawn this small piece here. This will isolate the center pin from the sleeve, outer sleeve. so hopefully I managed to 3D print it. It's quite small with fine details, so we'll see. Sorry for the sound, my main mic is currently charging, so but here is the 3D print. So small and so brittle. Ha! I think it worked. So this should go inside there. Ha! And this part here will go through the sleeve and should be flush with the other end. So I will drill a 5mm hole in the other end after I have parted the sleeve. Now I'm gonna install my collet so I can fasten it without making any ugly marks on it. This is the ER25 collets. And I have invested in a collet ring with a bearing that follows when I insert my collets and tighten them. So big lathe needs big tools. That should be tight enough. Hopefully. hopefully this piece is finished. Let's see if my 3D print fits. So if you look here, there's barely scratches from the collet, and if I had used my chuck, it would be deep grooves from the jaw on my chuck. So collets is a very handy thing to have when you're turning small parts and brittle and aluminum. So let's see if the 3D print fits. It's a bit short. Oh yeah. So I needed to adjust my 3D print a bit. So it's a bit shorter on the thick side and a bit longer on the thinner side. So hopefully it will fit now. There. It's flush with the aluminum. Just need to take off a bit more on the back here, but maybe I'll leave it for the lid for now. So then this piece is finished. Then we can make the probe tip in the center. And for the probe tip, I'm also gonna use aluminum, a bit thinner piece here. So I'll change my collet. So my memory card got full and I lost a video where I made this center pin, but here it is, not much to it. So I got the new 3D printed sleeve inside the outer sleeve here. Then I'll insert my pin. So as you can see, the center pin is isolated from the outer. Then I use a spring from a pen. Quite simple, it fits quite well. And got a reasonable amount of tension on the center pin. So let's see if it fits. Fits like a glove. But I think it got a bit too flush with input there, or a socket, so because I want to make a cap on the back side here, so to do that I need the height. I need the contact to sit a bit higher in the socket, so more like this. So I think I will make a new sleeve, outer sleeve here. Make this part new, a bit longer, so it will stick out from the socket a bit more. So I can make a decent cap on the back side to hold the spring inside. But quite happy with the design so far, except for the length of this part. But before I go any further with the parts making here, I want to see if I got contact between the center pin and the socket. So this is the center pin. So it's look like I have a good contact here. And it's isolated from the negative side. Measure if I got good contact here, and I do. Good enough. And it's isolated from the center pin. Ha! Very good. So I'll clean the socket with some electronic cleaner. Maybe some corrosion after all these years. But I think this worked well. I maybe will round the tip a bit more, or flatten it so it gets more contact surface. I think that would be smart to do. So now I will make a longer piece here. Then I'll be back. So I am this far with my parts. So I got a bit longer sleeve with threading on for a 3D printed cap. Then I got a spring from a regular pen and my center pin. I will make a new center pin with a more rounded tip for more contact, so or more contact surface. So this goes in here, then the spring, Then the cap screws on the back here. Oh, there I got a contact plug that fits the socket on the signal generator. So when I got a more rounded center pin, I can solder on my wires. I'm thinking about just putting a BNC connector on the back here, so I can plug my test lids directly on the BNC. That would be a bit more universal than having a fixed pair of test lids. Quite happy with my plug now. Flatten out the needle a bit in the pointy part, so it got more surface area to contact with. That lowers the resistance. So maybe you're sitting there and thinking, hey Marius, you can't solder wires to aluminium. And both yes and no. You can solder to aluminium, but I'll show you what my plan is. Maybe it will work, maybe not. So I'll take the center pin out again, and we will go to the lathe, and I'll show you my trick to connect my wire to the center pin. Set up my center pin into my lathe. I'm using the collets. Gonna drill a hole in the center. The center tap is 2.5 millimeters. There. Then I'm gonna take out the center pin from the chuck here. Call it chuck. Then to the next station. So here I have my center pin in my vise. I'm gonna take some solder flux and fill the hole I made with flux. And I'm gonna heat it up. There. Then I'm gonna add some more flux. Then add my solder. Fill the hole up with solder. Then I'm gonna find my wire. Then I'm gonna heat up the center pin again. Carefully and add some flux to my wire. Let it sit for a bit. Then remove the heat. Try to hold the wire still until it cools down. The solder cools down again. So the dirt on the pin comes from the flux. It's the resin that gets black or shard. So now we can take a tug test and see if my wire sits. This doesn't come loose again. This will sit plenty enough. Oh, still a bit hot. Cools quite quickly when you are heating aluminium. So here is the result. Wire is attached to the center pin. So I have my lid. I have made another hole into the lid. It goes through. That's for this terminal connector here. So this will sit like this. Then I'll solder my center pin wire to the connector in the center. Then the pin from the connector that sits on the outside here will hopefully hit the aluminium on the sleeve and make contact there. So then I don't need any wire to connect my negative side. So first I'll tin my wire. There. Then I need to add the spring. Now I can't miss any parts. So I'll use the clamp here to hold the spring a bit back, so I got it free from tension where I'm gonna solder. Then it has to go through the lid. Then I'll tin my my plug here, or my terminal. Then I'll solder a wire to the connector. There. Got blob of solder here. So I'm a bit sparse with my heat and soldering this. I'm afraid of melting the plastic. So there. Then I need to glue the terminal onto the lid. So I see I got a bit high point here, so I'll make it a bit more flush. That's after drilling. It's got some plastic that had built up here. So I'll remove that. So the excessive plastic is removed, so it's flush with the lid. So now I can glue the terminal onto the lid. So now I got the terminal glued on and connected to my test plug here. And let's measure and see how the resistance is between the terminal and the contact connections. So I'll rel out my meter here. Quite high resistance in my lids. There. Try to avoid the glare from my lighting over my bench here. There. So take the negative pin first. 2.8 ohms. That's good. Then the positive pin. 1.6 ohms. Very good. It wanders a bit, so you got some wiggle room because you have to have the spring that presses onto the test plug. But this is good enough for using the function generator. So I am very happy with my result here. I have a functioning plug for my function generator. So now I can use it when I have repaired it and restored it. So a bit sad that I didn't find any original plugs for this kind of sockets, but this will do. So yeah, until next time, bye.